Hi everybody, today we're going to talk about rational numbers. Before we get into using rational numbers, I think it's important for you to understand what exactly a rational number is. The term rational number is important when we're talking about classifying numbers. So when we talk about classifying numbers, this means that we want to know what categories a number fits into. The first main category is rational numbers. A rational number is any number that can be written as a fraction. So some examples of some rational numbers would be the number 7, because you could write that as a fraction, 7 over 1. Another example would be 2/3, because it's already written as a fraction. How about negative 7.5? That's also a rational number because it can be written as negative 7.5. So these are all rational numbers. Now, if you decide that the number is not rational, then it cannot have any other labels or categories. Here's one way to think about it. Everyone has a name, like my name is Jamie, Christine, Smooty. I have 3 names. Some people only have 1 name, like Beyonce, but I have 3. Actually, I guess Beyonce is Beyonce Knowles, so she has 2. Okay, so what I'm saying is that numbers can actually be named. They can have 1 name, 2 names, 3 names, or 4 names based on what categories that they fit into. So if you decide that you have a rational number, that means it can actually also have additional names. So rational would be its first name, and then we're going to talk about some other options for its middle name and last name. It may end up having 4 names, but that's okay. If you decide that the number is not rational, though, then it cannot have any other labels or categories or names. So if it's not rational, then that's all it is not rational. An example of a number that is not rational would be something that cannot be written as a fraction. For example, pi. Pi is a decimal that goes on forever, it never repeats, and it never ends. Or if I gave you the number 4.62357 doesn't repeat and doesn't end, that means it's not rational. How about a repeating decimal? Like, let's say 0.3 repeating. Is that going to be rational or not rational? Does it look like pi? Does it look like a decimal that goes on and on forever and never repeats and never ends? No, it does repeat. And we can write it as a fraction. 0.3 repeating is really just 1/3. So that means repeating decimals are rational. Okay, now let's talk about some of those other names that rational numbers can have. Rational numbers can be then broken up into other categories. Rational numbers can also be whole numbers, natural numbers, and integers. Whole numbers are all of the numbers counting upwards starting with the number 0. So 0, 1, 2, 3, 4, 5, 6, 7. One way that you can remember that it starts at 0 is because the word whole has an O in it and that looks like a 0. Now, natural numbers are the numbers that you naturally learned when you were little. So usually when you're a baby or when you first start talking, people ask you, how old are you? And the baby will say, I'm 1 year old. Or maybe they're 2 years old, 3 years old, 4 years old, and on and on and on as they get older. Now, do you expect babies to say, oh, I'm 2/3 years old? No, they don't say fractions. Or I'm 0.5 years old. They don't say that either. So think of natural numbers as numbers that you would expect a little child to know. Numbers that they can count on their fingers. 1, 2, 3, 4. Easy as that. And then integers, we spent a whole chapter talking about integers. Remember, integers are the numbers that are up on the wall on our number line. And so integers would be negatives, 0, and positive numbers, but no fractions or decimals. Okay, so now let's go through some examples and decide what types of numbers or what types of names we can give the following numbers. Let's start with -6. You should be writing this in your notebook. So -6, first thing I want to ask you is this number rational or not? Well, in order to figure that out, you ask yourself, can I write the number -6 as a fraction? Yes, I can. I would write -6 over 1. So since it can be written as a fraction, that means -6 is a rational number. And I'm just going to abbreviate that. Now that I know that this number is rational, I can go ahead and check and see if it's a whole number, a natural number, or an integer. Is -6 a whole number? No, because take a look here at our list. These are just positives, and 6 is negative in this problem. How about natural numbers? Do little kids know how to say -6? No. How about integer? Yes, this is going to be an integer. All right, now let's go to 2/3. Is 2/3 rational or not? Remember, a rational number is any number that can be written as a fraction. Good. Since this one is a fraction, this is also going to be rational. Now that we know it's rational, we can ask ourselves, is it a whole number, is it a natural number, or is it an integer? In this case, it's none of them. 2/3 is not a whole number, it's not a natural number, and it's not an integer. All right, next one, 0.75 or 75 hundredths, rational or irrational? It can be written as a fraction, 75 hundredths. So this is rational. Is it a whole number, a natural number, or an integer? No. All right, and the last one, the number 10. 10 can be written as 10 over 1. So this is a rational number. Is it a whole number? Yes. Is it a natural number? Yes. Is it an integer? Yes. So that one has 4 names associated with it. Okay, so now let's go ahead and talk about writing rational numbers as fractions. Like we said before, a number that can be written as a fraction is called a rational number. Some examples of rational numbers are shown below. If you take a look, we have 0.75, which is the same as 3/4. Negative 0.3 repeating, that's negative 1/3. 28 can be written as 28 over 1, and then 1 1/4 can be written as 5/4. So this first part here, we're going to write each rational number as a fraction. So when it says write it as a fraction, I realize that letter A already looks like a fraction, but it's really a mixed number. And so what we're going to do is we're going to write that as an improper fraction so that it's in fraction form. If you don't remember how to do that, remember you start at the bottom. You take 3 times 5 plus 2. So that would be 17. And then the denominator stays the same. So 5 2/3 is the same as 17/3. To write -3 as a fraction, we would just write -3 over 1. So go ahead and pause the video and then write 1A and 1B as fractions, and then play the video to check your answer. Okay, let's see how you did. So here on 1A, we're going to go ahead and do the roundabout. So 4 times 4 plus 3 would be 19. And then the denominator stays the same. So 19/4, 1B would be equivalent to 7 over 1. All right, next step is to write terminating decimals as fractions. So we spent a lot of time writing fractions as decimals. Now we're going to go backwards. This is where you're going to have to remember your place values. If you notice the chart over here on the right. After the decimal point, we have the tenths place, the hundredths place, thousandths place, 10,000ths place. So this first example is kind of already done for us. At least it's placed into the chart. So what we want to do is we just want to read whatever number is after that decimal point. It's a 48. That's what goes in the numerator of our fraction. And then in order to figure out what goes in the denominator, you want to look at the number that is in the last place. And that would be the hundredths place. And so that means we put a 100 on the bottom. Now the last thing you need to do is always make sure you reduce your fractions all the way. And I should see your steps on your paper. So we need to break this down. We can divide the numerator and the denominator by 2's. That would give us 24/50ths. If I divide by 2 again, that's going to give me 12/25ths. And that's going to be as far as I can go. So my final answer here is 12/25ths. Let's go ahead and try one more. Now this one's going to end up being a mixed number because if you notice, there is a 6 in front of the decimal point. So we're going to have a mixed number with a 6 in the front. Now we're going to just read what the numbers after the decimal point are. We have 375. And then we just need to know what place is the 5 in. And so again, we can kind of come over here and check our chart if we need to. The 5 is in the thousands place, and so that means we're going to have over 1,000. Now again, I told you that you needed to simplify all of your fractions. This one might take a little bit longer, but you still need to do it. So you can think of some numbers that can go into 375 and 1,000. Off the top of my head, I can think of 5 and 25. The bigger the number, the less steps you're going to have. So why don't we try dividing by 25 and see how that works. So 375 divided by 25. That's going to give us 15. And in the denominator, 1,000 divided by 25, that's going to give us 40. Ooh, it looks like we're close. I think we can divide by 5 again now. So we get 6 and 3/8. And that's going to be our mixed number. Okay, you're up next to try it. Go ahead and pause the video. Write the following problems in fraction forms. Make sure you reduce your answers and then play the video to check your answers. I've included the chart below so that you can see your place values as you're working. So go ahead and try it. Okay, and voila, here are our answers. Go ahead and check and see how you did. For the first one, we end up with 56 over 100, which is 14/25. And then for the second one, 5 and 875 thousandths. Might have taken you a few more steps, but that's okay. We should have all ended up at 5 and 19/20. All right, the very last thing we're going to talk about today is writing repeating decimals as fractions. Now we're going to go into just the very basics here in this lesson. One way that you can think of repeating decimals is if you think of this number right here, the number 8 that is being repeated. Now it looks like it's in the 10ths position, but since it is a repeating decimal, we actually say that it is in the 9ths position. So to write 0.8 with the repeating bar as a fraction, instead of writing 8/10ths, we're going to write 8/9ths. Now, you may not be convinced that that's actually how you do it, so if you wanted to check, you could take 8 divided by 9 and see what happens. So 9 goes into 80 8 times, that's 72, and then bring down your 0. 9 goes into 80 8 times, that's 72. Are you convinced yet? 9 goes into 80 8 times, so see, it does end up being 0.8 repeating. You can also think of 1/3. How could you get a 9 in the bottom? You would multiply by 3. So 1/3 is the same as 3/9, or 0.33333. All right, if you have two numbers repeating, instead of doing the hundredths place, which is where it finishes, we're actually going to do the 99ths place. So this would be 45 over 99. And then you would go ahead and reduce it. So we could divide them both by 9 here. This is going to give us 5/11ths. So our fraction is 5/11ths. Again, if you're not convinced, you can just go ahead and do the division. 5 divided by 11. 11 goes into 50 4 times. That's 44. So then when you subtract, you get 6. Bring down the 0. It goes in 5 times. That's 55. You subtract and get 5. Bring down the 0. 11 goes into 54 times. See how now it's starting to repeat. So you do end up with 0.45 with the bar over both the 4 and the 5. If you have 3 numbers repeating, maybe you can guess what that would be. If 1 number is repeating, it's a 9. 2 numbers, 99. And then 3 numbers would be 999. Now that is just the basics of how to write a repeating decimal. There are other types of repeating decimals that we are not going to go into in this lesson. So good job for today. Thanks for following along.